Hi there. Today we're going to be finishing up our unit 2B.7, which is on the rational zero theorem. And what we're doing is we are finding all the zeros of the function. And one of the things we looked at the other day is to use our graphing calculator to help us. What we said is that we can put the function into the graphing calculator, look at the x-axis for zeros, but again, we always want to verify using synthetic division, and then once it's a quadratic, we're going to solve on our own. So the issue is that let's say that we do this and we don't end up with a quadratic. What the heck are we supposed to do? Well, what we do is we look at the graph and we try another zero. Now, when you have a quadratic, you might be able to factor. If not, don't stop. Remember, you can always use the quadratic formula, okay? So a couple things to point out here. If we don't have a quadratic, what we're going to do is look at the graph and try another zero. And what we do is we're going to use the new coefficients in the synthetic division. Okay. We'll do an example together. Don't worry. Okay. And then again, we always keep going until we find a quadratic. And if we're not able to factor, we can always use the quadratic formula to help us out. All right. So what we're going to do is we are going to find all zeros of the function, but this time we have a quartic polynomial instead. And so this is f of x equals 2x to the fourth plus 5x cubed minus 18x squared minus 19x plus 42. So the first thing we want to do is make our P over Q list. And when we have a question like this, if it's like we don't have to simplify everything that we're doing, but we can just kind of think about what we would have. So I'm going to think about my factors of 42. So I have plus or minus 1, 2, 3 goes into 42. 4 doesn't, 5 doesn't, 6 does, and it's 6 times 7. 3 times 14, 2 times 21, and then 1 times 42. And then factors of 2 are 1 and 2. So remember, all the possible zeros are 1, 2, 3, 6, 7, 14, 21, and 42. So we can divide all of these by 1, or we can divide all of them by 2. So a half, 1, which we already talked about, 3 halves, 6 halves, which is 3, which we've used already, 7 halves, 14 halves, which is 7, which we've used already, 21 halves, and 42 halves, which is 21 that we've used already. So these are all numbers that we can kind of keep in the back of our head and look for, okay? But because this isn't factorable on its own, what we're letting you do is we're letting you put this in the graphing calculator. So we can just put in 2x to the fourth plus 5x cubed minus 18x squared minus 19x plus 42. And I'm going to zoom 6 it. Okay. So it looks here like maybe, it doesn't look like it's quite negative 1, 2, 3, 4. It doesn't look like it's negative 4, but negative 4 isn't on our list. So if we were tempted to try negative 4, that's where we look at our P over Q list and we're like, oh, negative 4 isn't even a possibility. But negative 2 is, that looks like it could be 1. Maybe a positive 2 over here. So let's kind of see, okay? What happens when we do that? So we're going to, I lost my pencil. So we're going to test, let's test negative 2 because negative 2 is on the graph and we see that it's a possibility in our P over Q list. So let's try to see if negative 2 is a 0. There aren't any missing degrees. So I can just put my coefficients in here, okay? And I'm going to bring down the 2. multiply, and I get negative 4, add, multiply, and add, multiply, and add, and you don't have to do this as fast as I do, but we see that we do get this 0 that's here. So it is a 0 of the function, okay? So let's think about what's left, because sometimes you're able to factor what's left. We would have 2x cubed plus x squared minus 20x plus 21 equal to 0. Okay, again, we started with an x to the 4th. When we divided it out by a linear factor, we're going to end up with a 2x cubed. Well, we look at this, and when we have 4 terms, sometimes we could factor by grouping. But when I look, I don't see a lot in common with the first 2 terms and the second 2 terms. And again, if you tried to factor by grouping, notice that we don't have matching factors that are here. So this is not factorable, okay? So we cannot factor. So what we're going to do is we're going to use another 0. Because if we use another 0, now we can turn this cubic into a quadratic. Well, sometimes what students will do is they'll say, well, I don't want to try any fractions, so let's try this 2, because it looks like maybe it crosses at x equals 2. So what we would do is we would use these coefficients, okay? We'd use the coefficients of what's called the depressed polynomial. Don't worry, it's not sad, it's just 1 degree lower than the original, okay? So what I would do is use 2, 1, oops, leave some space, 2, 1, negative 20, and 21, and I would see if 2 goes in. And so we do that, remember, by the remainder in factor theorem. It is a 0 if we get 0 as a remainder. But notice that when we do that, oops, I didn't do that correctly. I need to multiply 5 times 2. And that'll give me negative 10, negative 21. Okay, still it doesn't work, right? Nope. So that means that 2 is not a 0. So that means that I'm going to look at my P over Q list to kind of help out. Well, again, this one's close to negative 4, and that wasn't in our P over Q list. This one right here looks like it's between 1 and 2. So that would be like 1.5. Is 1.5 in my P over Q list? Well, I see that 3/2 is 1.5, and that's in my P over Q list. So as much as I might not want to use a fraction, it looks like we're kind of stuck because the integers that we're looking at didn't seem to work. So I'm going to try 3/2. Again, I'm going to use the new coefficients. Okay. And I'm going to bring down the 2. And then I'm going to multiply 3/2 times 2. Okay, if you need to write it out to look, that's fine. Notice the 2's cancel. We end up with 3. 1 plus 3 is 4. So now I'm going to take 3/2 times 4 over 1. And this time we get 12 over 2, which is 6. So negative 14. So now I have 3/2 times negative 14 over 1. Well, that's negative 42 over 2, which is negative 21. And look, we get that, okay? So we have another 0. So far for our zeros, we had negative 2, and we have 3/2. Let's see what's left. Well, we started with a quartic, we then had a cubic, and so now this is going to be a quadratic, 2x squared plus 4x minus 14, okay? So this is where we get pretty excited. Yay, this is a quadratic. And that means that we can stop the synthetic division process, okay? So what we can do is try to factor this. So let's try to factor 2x squared plus 4x minus 14. The first thing I would do is take out a GCF. So I have x squared plus 2x minus 7 equals 0. Okay, and if I try a double bubble, My only factors of 7 are 7 and 1. So there's no way that we're going to be able to get an outer inner that gives us 2. Okay? So this is the thing, is that we cannot factor. Okay? But the reason that a quadratic is awesome is because we can solve any quadratic using the quadratic formula. Okay? So we can't factor, but we can use the quadratic formula. Okay? And so the quadratic formula is where we have x equals, and I'm going to use these smaller coefficients instead. The reason that's legal is I could divide both sides by 2, and that would still give me like this equals 0. So instead of using 2, 4, and negative 14, I'm going to use 1, 2, and negative 7 as my A, B, and C values. So I'm going to have negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, so let's clean that up. That becomes negative 2. This is going to be 4, and this is going to be plus 28, so that's going to give me 32, and then 2 times 1 is 2. All right, now remember we want to try to simplify this by looking for any perfect squares. And I know I can turn 32 into 16 and 2. So that's going to be negative 2 plus or minus 4 root 2 over 2. And what I can see is that all 3 of these terms are divisible by 2. So I can divide each of these by 2. And I can get that x equals, that's going to be a 1 in the denominator. So that's just going to be negative 1 plus or minus 2 root 2. Okay? And again, that's something that we did in a previous unit, just using the quadratic formula. Now again, this wanted me to find all the real zeros, but don't forget about the ones that we found earlier. Do you remember these guys up here? These were also zeros of the function. So we also need to make sure that we include x equals negative 2 and x equals 3/2. Oops, sorry. So that's going to be those are going to be our solutions. So again, just don't forget when you're listing all the zeros to bring these down, okay, as part of your solutions, okay? So these are the ones from the quadratic formula. These are the ones that we use from synthetic division from the calculator. And notice that like we couldn't have gotten this using the graphing calculator exactly, right? We just would have had decimal approximations. So it's really nice to get it down to a quadratic, and then we can have exact answers. Now, I don't want you to think that we always should use the rational zero theorem in the P over Q list. Remember that there are other methods that might be more efficient if possible. So for example, if I'm looking at letter E, I'm not going to bust out my calculator and put that in. I have 4 terms. And one of the strategies that we looked at when we have 4 terms is to factor by grouping. So maybe instead of using the calculator, we could factor by grouping. Let's try it out. If I group these 2 together, I could factor out an x squared, and that would give me x minus 3. If I group these together, that gives me, I can take out a negative 1, and that gives me x minus 3. And look, that means that I'm able to use grouping. So again, if I'm finding the zeros of the function, I'm setting it equal to 0. And I do think that setting equal to 0 is important to put, because we know then that we don't stop after we're done factoring, that we actually do solve. Okay, so one of my factors is going to be x minus 3. And then I use these coefficients as the other factor, so x squared minus 1. And then I see if I can factor any further. Oh, that's a difference of 2 squares, so that's going to be x minus 3, and then x plus 1, x minus 1. And because it's an equation equal to 0, I'm going to need to set each of these equal to 0. If I set x minus 3 equal to 0, I get that x equals 3. if I set this equal to x plus 1 equal to 0, I get -1. Setting x minus 1 equal to 0, I get +1. You can list them separate, or we talked about we can use plus or minus if we have one of each. Okay. What about letter F? I know that in letter F, I have a quartic, but should I use my graphing calculator to help? Or do you see something special about that we could maybe use? Well, one thing that I notice is that this looks like it's in one of those quadratic forms where this is like this, like the x squared, like this exponent is double the one in the middle. So maybe what I could do instead is make a double bubble. And to make x to the 4th, I could use x squared and x squared. Okay, and to make 100, I want things that multiply to 100 but add to 29. So how about 25 and 4? Oh, that'll work perfect. So so plus 25 and plus 4. That multiplies to make 100, and then the outer 4x squared and the inner 25x squared make the 29x squared. Okay, so now we keep factoring if we can. And even though it's super tempting because these are perfect squares, you guys, it's not a difference of 2 squares, so this is not factorable. And we'll see why when we solve. Again, just because it's not factorable doesn't mean we can't solve it. What we can do is think about setting each of these factors equal to 0. And if we solve, I end up with x squared equals -25. And then I would need to take the square root with the plus or minus. And because I'm taking the square root of a negative, I have to introduce I. So I'm going to have plus or minus 5i. That's why we couldn't factor that, because we can't factor using our methods with imaginary values. Okay. So then over here, I could subtract 4. Again, take the square root, think about plus or minus. And this time I end up with plus or minus 2i because 4 was a perfect square. And the square root of -1 would give us the I. So these would be the solutions, okay? And it's true that they're not real solutions, but it's really nice to be able to find all the zeros. Because again, if you have a quartic with to the 4th power, that means that there should be 4 zeros. Some of them may be repeated, but in this case, we have 4 distinct zeros, 5i, -5i, 2i, and -2i. Okay? So that should get you going with that. So again, the rule is use the calculator to start. If you have a quartic, then try another one until you get it to be a quadratic, and then you can either factor or use the quadratic formula to help us out. Okay? All right, you guys, I hope you have an awesome day.